All right, so um, today let's dive into OpenShift virtualization storage. And you know more specifically what happens when you don't have a CSI driver. So you've got your OpenShift cluster all set up your storage system, maybe something like the Lenovo ThinkSystem D2000, but there's no CSI driver to actually like connect them. It's kind of like showing up to go camping with all your gear and realizing, oh shoot, I forgot the tent poles. Pretty frustrating, right?
Yeah, it could definitely throw a wrench in the works.
Yeah.
CSI drivers, they're supposed to make storage management seamless, kind of like a universal adapter, so your cluster can talk to any storage system. Without it, you've got to find some kind of workaround. And thankfully, OpenShift virtualization is built to be flexible.
Okay, so before we get into all the workarounds, I think it'd be helpful to just take a step back for a second. Could you explain what a CSI driver actually does, like in a way that someone who's not a storage expert would understand?
Sure, so imagine you have all these different devices, and they all have their own unique power plugs. A CSI driver is like that universal adapter that lets them all plug into the same outlet. In this case, the devices are like your storage systems, and that outlet is your OpenShift cluster. So the CSI driver handle all the translation between the two, making sure they can communicate and work together smoothly.
Okay, that makes a lot of sense. So without that universal adapter, we need to find other ways to power those devices. So what options do we have when a CSI driver is missing?
Well, there are a few different paths you can take. Each has its own trade-offs. For smaller projects, especially like proof of concept setups, you might start with the local storage operator, or LSO, and pair that with OpenShift Data Foundation, or ODF.
Okay, LSO and ODF, tell me more about this dynamic duo.
So LSO, it's like a resource scout for your local storage. It goes to each worker node in your cluster, and it identifies any available storage capacity. You can think of it like it's gathering up all those spare SD cards and USB drives you've got lying around. Put it into good use.
So it's taking those scattered resources and making them available to the cluster.
Exactly, and that's where ODF comes in. It takes those aggregated resources, creates a unified storage pool, adds in features like replication and thin provisioning, kind of like taking all those scattered storage devices and organizing them into, a well-structured, easily accessible library.
Okay, so for smaller projects, especially those where performance isn't the top priority, LSO and ODF sounds like a pretty elegant solution.
Hmm.
But what if you do need high performance, like for a database or a real-time analytics application?
In those cases, you might consider direct access through Fibre Channel. It's a dedicated high-speed connection, bypasses the need for a CSI driver, offers the lowest latency and the highest throughput. Imagine you need to transport something super fragile across a bumpy road. You'd want a vehicle with the best suspension right. Fibre Channel is kind of like that high-performance vehicle for your data.
All about speed, minimizing those bumps in the road, but I'm guessing there's a trade-off here.
There is. While Fibre Channel offers like top-notch performance, it does require more manual configuration. It's kind of like driving a manual transmission car. You have more control, but it takes more effort to operate.
Okay, so for those situations where every millisecond counts, Fiber channel might be the way to go even with the extra configuration involved. Now, what about those situations where you need something in between, something that can handle external storage, maybe even multiple storage systems, but without all the complexity of fiber channel?
Well, that's where ODF really shines.
Yeah.
It can act as middleware, bridging the gap between OpenShift and those external storage systems.
Hmm.
Imagine ODF as a skilled diplomat,
Yeah. Oh, yeah.
negotiating between OpenShift and those external storage systems that speak a different language.
Wait, so ODF isn't just for local storage, it can manage external storage as well, even without a CSI driver.
Exactly. It can dynamically provision storage from a bunch of different sources, including those without native CSI support. It can even pull resources from multiple systems, creating a unified storage layer. It's incredibly versatile.
That's impressive. So we've got a few options on the table now. LSO and ODF for smaller local storage needs, fiber channel for those high-performance scenarios, and then ODF stepping in again as a versatile option for managing external storage. But what about those situations where you need like complete granular control over your storage, even if it means doing things manually?
In those cases, you can always go back to basics and provision raw volumes. It's like building your own furniture. You have complete control over every little detail, but it takes more time and effort.
So with raw volumes, we're essentially defining the storage ourselves. using OpenShift's API to carve out exactly what we need.
That's right. You define the size, the location, all those other parameters manually. Then you make those volumes available to applications through persistent volume claims or PVCs. It's a very hands-on approach for those who need absolute control.
So it seems like we have a good range of choices already, even without a CSI driver. Are there any other options that we should consider?
Sounds like you've got a good handle on the alternatives already. OpenShift virtualization really does offer a lot of different tools for managing storage, even without that CSI driver.
Yeah, it is amazing how adaptable it is. It's almost like it anticipates, those real-world scenarios where you
Well,
might not have the perfect setup. So we've talked about LSO and ODF for that local storage, Fibre Channel for high-speed needs, and then ODF again for managing that external storage. We even touched on, raw volume provisioning for those who like to, get their hands a little dirty.
you've hit all the main points. It is worth emphasizing, though, that choosing the right approach really depends on your specific use case and, of course, your priorities.
Right. It's not one size fits all. Can you give us some examples of, when you might choose one option over another? Like, when would all that extra configuration effort for Fibre Channel be worth it?
Sure. Imagine you're running a high-frequency trading platform. Every millisecond counts. Even a tiny delay in data access could mean, the difference between a profitable trade and a missed opportunity. In that scenario, the raw speed and low latency of Fibre Channel, that would be absolutely critical, even if it means a bit more work up front to configure everything.
So it's about weighing that cost of configuration against the potential impact of even a tiny delay. What about LSO and ODF? You mentioned they're good for smaller projects. What kind of projects are we talking about?
Well, think about a development team that's testing out a new application. They need storage for their testing environment, but they don't need massive amounts of capacity or, those super fancy enterprise-grade features. LSO and ODF, they're perfect for that. It's a really simple and streamlined way to provision local storage and, just get up and running quickly.
So it's like choosing the right tool for the job. You wouldn't use a sledgehammer to hang a picture, and you wouldn't use a thumbtack to build a house. What about ODF as that middleware? What makes that the best choice in certain scenarios?
ODF as middleware. It really shines when you've got diverse storage needs within your OpenShift environment. Let's say you have some applications that need high-performance storage, and then others that are more focused on capacity or, cost efficiency. ODF can manage all those different storage systems. It create that unified storage layer that makes things easier to manage, and it can even improve resource utilization.
So it's like ODF is the storage orchestrator, bringing harmony to, this potentially chaotic mix of storage systems.
That's a great way to put it. It abstracts away all that complexity of managing multiple storage backends,
Yeah.
so you can just focus on your applications and workloads.
This is all making a lot of sense now. But I have to admit, with all these workarounds that are available, I'm kind of starting to wonder, will CSI drivers eventually just become obsolete? I mean, if we can manage storage just fine without them, why even bother?
That's a really insightful question. While these workarounds definitely show just how flexible OpenShift virtualization can be, I don't think CSI drivers are going away anytime soon. They still offer some really big advantages in terms of standardization, automation, and ecosystem support.
So it's not really a case of one approach replacing the other, but more like having, a whole bunch of different solutions that can meet all those different needs and preferences.
Exactly. It's like having a toolbox full of different wrenches. Each wrench has a specific purpose, and a skilled mechanic knows which one to use for each task.
Okay, that makes sense. But if CSI drivers are still so valuable, why aren't they always available? Why are we even having this conversation about workarounds in the first place?
That's a great question, and it really highlights how much the storage world is constantly changing. The CSI specification is relatively new, and not all storage vendors have jumped on board yet.
So it's a matter of catching up. Are we likely to see, more widespread CSI driver support in the future?
Absolutely. As the CSI spec matures and gets adopted more widely, we're going to see more and more storage systems offering native CSI driver support.
That's good to hear. But for now, it seems like knowing these workarounds is essential for anyone who's working with OpenShift virtualization. Speaking of workarounds, we haven't really talked that much about raw volume provisioning.
Right, we just briefly touched on it.
Why don't we dive into that a little bit more? When would someone actually choose to go down that raw volume path? It sounds pretty labor intensive.
Yeah, it does feel like going back to dial-up when everything else is high speed. So when does it actually make sense to choose raw volume provisioning, in this age of automation?
Well, imagine you're a system admin who really likes having that control.
Right.
Wants to fine-tune like every single aspect of the storage setup. Raw volumes give you that granular control. You're basically defining the storage architecture yourself, using OpenShift's API to create those persistent volumes with very specific characteristics. So it's for those who really like to roll up their sleeves and, get under the hood. But isn't that level of manual configuration kind of risky? What if you make a mistake?
It does require a pretty good understanding of storage concepts.
Yeah.
And you know how OpenShift works under the hood? So there's a higher chance of human error compared to those more automated approaches. But for some very specific cases, that trade-off is acceptable.
What kind of cases are we talking about? When is that level of control absolutely necessary?
Think about scenarios where you need to optimize for like very particular performance. Or, maybe you have some strict security requirements. Let's say you're working with really sensitive data and you need to make sure it's stored on like dedicated hardware that's physically isolated. Or maybe you have an application that has some really unusual I/O patterns that need a very customized storage configuration.
So it's like having a bespoke suit made, it fits perfectly, but it
Yeah,
takes way more time and expertise to create.
exactly. Raw volume provisioning gives you that level of customization and control.
I see how each of these approaches, kind of has its place. It all depends on what the project needs. But before we wrap things up, I'm kind of curious about your thoughts on the future of storage management, in OpenShift virtualization. Do you see any trends emerging?
I think we're going to see a big push toward automation and simplification.
Mm.
Even as the underlying storage technology gets more and more complex, CSI drivers are going to be a big part of that evolution. Providing that standardized interface for managing a whole range of storage systems, we might even see, AI-powered storage management tools that can automate things like provisioning, optimization, even troubleshooting.
So even though we've been talking about all these workarounds, it sounds like the future holds even more streamlined and intelligent solutions.
Absolutely. The goal is to make storage management as seamless as possible, almost invisible, really.
Mhm.
So developers and admins can focus on what they're best at, building and deploying awesome applications.
Well, on that note, I think we've covered a lot of ground today. We've explored, all the ins and outs of managing storage and OpenShift virtualization, even when a CSI driver isn't an option. We've looked at, simple and straightforward options, and then complex and customizable ones, really highlighting, how flexible and adaptable this platform can be.
It's been a great discussion. I hope our listeners feel a bit more confident now about tackling their own storage challenges, knowing that OpenShift virtualization gives them a bunch of different tools to manage storage effectively.
Absolutely. And remember, the key takeaway here is to choose the approach that really aligns with what you need. And you know what your priorities are. Don't be afraid to experiment. OpenShift virtualization is made for that.
Well said.
Yeah.
And don't forget, the storage world is always changing. Stay curious, keep learning, and you'll be ready for whatever comes next in storage management.
That's a perfect note to end on. Thanks for joining us for this deep dive. Until next time, keep exploring.